Hello guys, my name is Saurav and I'm a product manager at booking.com. I work in the payments department and today I'll be sharing with you guys my thoughts around A/B experimentation 101. As it's public knowledge that booking.com is a company that relies heavily on the data-driven approach, and we do all our rollouts and all our changes through experimentation, and we're widely known for that. So I would like to give you just a basic class on A/B experimentation for those of you who are not very familiar with it. And also, I'm happy to deep dive into specific topics, etc. If you guys are interested in something to know more, you can always reach out to me through LinkedIn, and I guess you can find my details on the product school page. Okay, let's start. So let's start with the objective of this presentation or workshop. Before pre-COVID times, I usually used to do it as a workshop, but okay, what you'll get out of it is a basic understanding of A/B testing, what it means, when it should be used, etc. How can it be used as a form of validation of your changes, how to collect data and how to interpret the results, and how to formulate a good hypothesis and measure the results. Uh, okay. And you should be able to understand better the business objectives set by product teams by the end of the workshop, and translate them into experiments and break them down into smaller and multiple experiments and formulate relevant hypotheses to prove your impact. This could be relevant not just for product managers, but also for designers, developers, and anyone that's part of a product team. At Booking, we don't restrict our experiments to product managers only. Yes, we are at the forefront of it, but like everyone in the company is familiar with experimentation and the tool, and we give everyone the right to run experiments. Cool. Let's start with an example, right? So I have two screenshots here. They're from the website Decathlon. And I just want you to compare the left side, let's say that's the base, and the right side, that's your variant, and basically look at the difference, right? So you can find that there are in total three things that are different here, right? The bike is different on the right side. It's a road bike compared to a city bike on the left. The image is significantly larger. And if you notice closely, there's also like a change in the order of the text here. In the right, they've shifted road bikes on top. So is this a valid experiment to run? That's what we are trying to answer here, right? Now, the thing is, a simple A/B comparison is not possible in this case because there are too many changes and too many variables. So the idea is that for A/B experimentation, you try to isolate a single change so that you can understand the impact of that change in particular. In this specific case, let's say you see that whatever is your primary metric works well in the variant, but you cannot attribute it to whether it's because of the image, the size of the image, or the text, right? It could be that if you did one or let's say all these three changes in separate experiments, two would have been positive and one is negative, and which means you could have more impact with those two changes compared to all three together. This is just an example, and now we can see this is another example. Is what I just changed, and basically here the only difference is that you increase the size of the image. Everything else remains same. So this is a good example of an A/B test, and you can really compare the impact of base versus variant and the impact the size of the image has on your change. Cool. Now, there are a few things when we talk about experimentation that we need to know. So there's primary metric, always a North Star metric. It could be something set by your company or organization. It could be different in different experiments. Some companies don't have North Star metrics. Then there are always like some supporting or secondary metrics, as we call them. Then there are health metrics and binomial goals. So I'm going to explain and walk you through all of these. And let's start with the primary metric. So in the previous example, when we saw two bikes, the primary metric could be what do you want to achieve at the end of the day? Let's say more sales or conversion, right? So it's just an example, but you could also run that test with the primary metric being the number of clicks on that category, right? Ideally, it depends on the approach taken by your company. Ideally, a primary metric should be a North Star metric, and that should be able to show business impact. And when you run a test, you should always aim for a conclusive change in a primary metric. By conclusive, what I mean is it should be significant in terms of the data that you gather, right? And so what are supporting metrics? While you have only one primary metric for your A/B experiment, you can have several supporting metrics that can support your hypothesis, right? So, for example, in this case, you could have the number of clicks, the time spent, the funnel conversion, and different things, right? So a good example of e-commerce supporting metrics could be customer service tickets, number of returns, cancellations, how we are doing overall in terms of like the hypothesis and health of the product, right? And then we have the health metrics, which again differ from company to company. It's most probably defined by an organization or a tech team, but these are typically related to the health of your product, like your performance, your page load times, the speed of your website, the errors you see, the app crashes you have, etc. Right? So these are good to monitor in all experiments, so that you can find out that there are no unexpected changes in these health metrics. Finally, there are binomial goals. You could say all metrics are binomial goals, but basically you could these goals are basically measured in all experiments, right? So it could be your bounce rate, it could be your some of the health metrics. Every metric can be categorized as a binomial goals, but then you don't need to add them as part of your experiment criteria, but they are also good to monitor. So they give you like an idea of how your changes impact the overall website. Moving on, I have an example from a very old booking.com UI. Again, I cannot share very recent stuff. Those are company guidelines, so I'll just go through this example. So this is how our search results used to look like some time back. And these are two screenshots. Now, if we were doing this in person, I would try to ask you to identify the changes, but like I'm already giving it out here. So basically, it's just the spacing between your location and the description, right? Now, believe it or not, this experiment increased conversion to a great extent, and we can isolate the result, the attribution of the result to this experiment, because this was a single change that we measured. Again, you can ask, how did someone come up with the idea of this? It looks more probably like a bug that was missed by the developer, etc. Those are all valid points, but this is just an example that a small change could lead to such big impact. Cool. The next question that we get a lot, I get a lot, is typically how long should an A/B test be run, or like in general an experiment be run, right? There are two things to consider when you consider the runtime of a test. Basically, how much traffic do you need, and what is the minimum change that you want to detect, right? So I'll give you an example. The answer is not straightforward. So you have the website traffic, you have a base conversion rate of your primary metric. Let's take an example. If you're talking about conversion, let's say from your final checkout page to actual conversions, the conversion rate is 70%, right? So now from that 70%, do you want to be able to detect a change if it goes from 70 to 71? Or do you want to detect a change if it goes from 70 to 75 with the same traffic? I'll show you with an example here. But then those are two different runtimes, right? Because the more granular the change you want to be able to identify, the more time you need, given the traffic remains same and vice versa, right? So if the change remains same, the more traffic you have, the less time you need to run your test for. But as a rule of thumb, we always say that even if you have enough traffic and your change is not too big that you need to detect, it should always be run for 1 or 2 full weeks cycle. And this is to take into account any sort of diversity or seasonality, weekly seasonality that you might have in your customer behavior, right? Now you might say like people might behave very differently in holiday season compared to summers, etc. Those are valid points, but it's just not feasible to run experiments for a year long. So this is the best trade-off we can have. This is an example of a power calculator that can tell you how long you need to run a test. You can Google online, it's there from Optimizely. So basically, in the left and right, I'm showing base conversion rate is 30%. The traffic and the number of variants and how much users are tracked is exactly the same. Now, if you want to detect a change, like whether your change is going from 30 to 31%, then you need 37 days to run that experiment. But if you only want to detect a change, if conclusively, if it's going from 30 to 35, then you can just run for a day, technically, right? What this means is basically, if you run it for a day, and let's say you improve conversion by 4%, you will never know conclusively that it's true. I hope that makes sense. Yeah. So as long as it's not more than 5% impact, you won't have a conclusive result. And in the other case, if you run for 37%, you can detect up to 1% granularity. Cool. Next, we move on to the hypothesis. So every experiment, before you run it, should have a hypothesis. A hypothesis is basically why you want to run an experiment and what outcome you wish to have. So it's a nice saying that like if you don't have a hypothesis, like throwing spaghetti on a wall and see what sticks. So basically you are throwing stones in the dark and you don't know what you're aiming for, right? So hypothesis is usually the tool that protects us from all our own biases. So now next we look at how to formulate a good hypothesis. So a hypothesis could look something like this, right? So based on a certain evidence, it could be based on past user behavior or data that you've collected or talking to your users. It could be from research, etc. We believe that if we make this change, what is your change? For what type of users? It could be for everyone, or it could be very niche for logged in users from the Netherlands. It will help create what impact for them, right? So this is your core hypothesis, and then you have a validation for the hypothesis, basically. And how will you know your hypothesis holds true? So we will know that this hypothesis is true if we see, let's say you can say a reduction in customer support calls, or an increase in conversion, or increase in a reduction in drop-off rate, or increase in people going from search results to the product page, right? So we will know this is true if we see this change in the primary metric that you have. So all the ones I gave examples for could be good primary metrics. So, and why is this good for the business, right? So this is good for the business because if you increase this primary metric, then it affects certain business KPIs. A primary metric should always be able to correlate it with the business impact. So that's your cheat code to form a good hypothesis. Now you can of course have tons of more details in your hypothesis, but ideally this is the bare minimum you need. And a good hypothesis, remember, it protects you from your own biases, because once you see the experiment results, it's very easy to say, okay, I did not expect this, or I expected this, being biased from the results that you see. And people do it even unconsciously, right? So it's very important to formulate and have a good hypothesis before running the experiment. Cool. Next, I get a lot of questions, or we at Booking get a lot of questions. Typically, how many experiments do you run at a say given time, right? And the answer is like hundreds, sometimes thousands, right? And a lot of people ask, okay, isn't there interaction between these experiments, right? So the answer, there's no straightforward answer to that, but I'll give you an example in the next slides. But yes, there could be interactions if some things are very, very closely related. There could be impact from one experiment on another, but typically over a large enough data set, that impact seems to be distributed equally on both variants. I'll explain what I mean with this example, right? So let's say we are running two experiments in parallel. The first experiment is that your variant and has a different font than your base, right? So in this you can see like a sans font, Open Sans, and in this on the right you have a serif. And your experiment 2 is changing the color of the button. So on base you have a green colored button, in variant you have a yellow colored button. Now it's true that these experiments are very related, but what will happen over a large enough set of users and data is that the impact of experiment 2, the colors, will be equally distributed in the base and variant of the fonts experiment, right? So if I look at the base, which is this, the font stays the same. 25% of people will be exposed to green, and 25% of people will be exposed to yellow, while the font stays the same, right? So, and the same treatment will happen for people in variant. So over a large enough set of users and data, the effect of the green and yellow should be equal across the variants of experiment 1. I hope that is clear. Moving on. And finally, I think so. There's a lot of questions around. Okay, the A/B experiments are typically comparative experiments, right? So, what if you need to do a feature rollout or improvement where you're fixing a bug, where you're not necessarily expecting things to be better, but you just need to do it, right? Even there's a form of experiment that you can use for that. So it's called non-inferiority test. You can use them for feature rollouts, new products, and bunch of other things. I try to explain what that is. So typically, non-inferiority tests are experiments where you say that your variant is not worse than your base, right? So it is at par, or it is not worse by a certain extent, by more than a certain extent, right? So I'll give you an example what I mean. So this is again from Booking. A couple of years back, we introduced a feature called payment receipt, right? So this was actually done by my team, and I'm taking this example from payments. So you can see that this is base, where there's no receipt, no option for the user to get the receipt. And in variant, you see the print receipt option, right? So this was a feature that was creating a lot of CS inbound. We had requests from guests, etc., etc., right? And we needed to do it in some geographies because of legal reasons, like Japan. So you see here that we set up this experiment as a non-inferiority test. What this means is we are saying that our variant is not worse than our base. So my primary metric in this case was customer service tickets or contacts by guests, and I'm saying that the variant will not have more than 2% customer service contacts compared to base. and this is what you see is the non-inferiority threshold. And you can see that this is the limit that we have set, and the results you can see is 0.78% increase, but it's within the threshold, and there's a standard deviation of 0.92%, right? So this is a good enough result, and that's why the significance shows up as yes, because it is a one-sided test, and the results are valid based on your one-sided test. Cool. Finally, I would like to give you some more examples. Like I said, typically if you're doing this in person, I would like to do an exercise with you guys, but I think you guys can do it by yourself as well. So I will just try to tell you the problem statement. So basically, if you can by yourself, try to identify at least 2 experiments that are going on currently in Amazon.com. So what you need to do is basically open Amazon.com and open it in an incognito browser, so that your cookies are not saved, your details are not saved, and you can see the website experience as a new user would see it. And experiments are typically allocated randomly to different cookies. So every time you close, you need to close the window of the incognito browser and reopen again. You might be able to locate different experiments. Or if you can do it on different computers, that works as well. So that's what I mentioned. Experiments are randomly assigned based on cookies. Because you're not logged in, sometimes experiments are done based on your user account or email address, or if it's an app based on device ID. And try to identify, go to Amazon.com. If you can pause the video, pause it. Go to Amazon.com and try to identify 2 experiments that are currently being run. I would give you an example. These screenshots are taken like a few weeks back. But before we go to that, like the goal of the exercise is that you should be able to identify 2 experiments and formulate a good hypothesis on why Amazon.com would be running that experiment in the format that we discussed before, and what could be the primary and secondary and the health metrics for that experiment, right? Now, because we are doing it offline, I would give you 2 examples that I found. So here you can see, again, I did this on my browser on incognito a few weeks back. So by opening it multiple times, I could see different experiences and I took screenshots, right? So on the left, in both cases, I'm not signed in. On the left, you see that there is a carousel of recommended books, probably, or most popular books on Kindle. And on the right, that is missing. So that's one experiment. I don't know if it's still ongoing. You might be able to find the same, or they might be running other experiments. And there's another experiment ongoing, that on the right you see that there's a prompt to sign in, because I'm not signed in. Right now, this did not show up after a certain time period. Some of you might be wondering. It was just there the minute I opened the website. So this is definitely an experiment that's being run by Amazon. Right. So these are the kind of A/B experiments that are run by companies, and of course they have their own hypotheses and metrics. So let's talk about one. Let's take the carousel. The hypothesis for introducing the carousel could be that by introducing, let's say, top-selling books on Kindle by for new non-logged in users, we could help them navigate the website better, and that will lead in more people purchasing with us, or more sign-ins, whatever is your primary metric, right? So that's just an example. In this case, your primary metric could be more purchases on Kindle. It could be more sign-ins. That could also be a secondary metric. Your health metrics could be lower bounce rate, and so on and so forth. Yeah, and last but not least, like if you are well versed with the console. In some websites, if you open Amazon or some Facebook or some other website, it is not that difficult to find how you're tracked in experiments. So you can find some things going on there. These are cookies assigned to different experiments, and you might be able to locate them. And finally, if you have any questions, you can ask in the comment section, and feel free to reach out to me via LinkedIn. My handle is Saurav R. There's also a link here, and I'm always open for interesting product discussions, be it on experimentation or otherwise. So feel free to reach out, and thank you so much for listening to the talk and spending your time with me. I hope you'll have a good day. Thanks. Bye.